If you want to paralyze the global economy, you don't need a world war. You just need to block a 21-mile stretch of water. Today, we are talking about the Strait of Hormuz. You have heard that it is the most critical oil choke point on Earth. But if it's so important, why is the US Navy incapable of keeping it open? Why do multi-billion-dollar backup pipelines completely fail to bypass it? And why does this tiny geographic trap control a lot more than just the price of crude oil? Welcome to Growth. I'm Shen, and this is The Explainer, where we break down complex jargon so you can actually understand the systems shaping our world. First, you have to look at the map. Think of the Persian Gulf as a massive geological vault. Inside this vault sits the greatest concentration of heavy energy baseload on the planet. But this massive vault only has one exit door to the open ocean, the Strait of Hormuz. It is an incredibly narrow bottleneck sitting between Oman and Iran. At its narrowest point, the strait is only 21 miles wide. But the reality for maritime shipping is actually much more claustrophobic. Because the water is dangerously shallow, the deep water shipping lanes capable of handling massive oil tankers are only 2 miles wide in either direction. Through those 2-mile lanes flows a continuous, unbroken conveyor belt of heavy industry. Roughly 21 million barrels of crude oil every single day. That is a fifth of global consumption squeezed through a gap the width of a small city. Whenever tensions spike in the Middle East, many immediately point to the US Navy, especially in this one. The assumption is that the most powerful maritime force in history will simply escort the commercial ships and keep the oil flowing. But that assumption fundamentally misprices the math of a modern naval warfare. A US destroyer is a $2 billion asset. To shoot down an incoming threat, it fires an interceptor missile that costs roughly $2 million. The adversary, hiding in the mountainous coastline, isn't firing $2 million missiles. They are deploying mass-produced asymmetric drones and naval mines that cost $2,000. You cannot sustainably fire a $2 million interceptor at a $2,000 drone. Even if you ignore the balance shift, you cannot ignore magazine depth. A destroyer only carries about 96 missiles in its vertical launch tubes. An adversary embedded in the coast has infinite ship ammunition. The Navy mathematically runs out of interceptors before the enemy runs out of drones. So the armchair generals may pivot to the obvious solution. Stop using billion-dollar destroyers. Send in a swarm of small, cheap patrol boats to escort the tankers. But that misunderstands the physics of radar. Those $2,000 drones are just the decoys designed to blind the sensors and drain the ammunition. The actual kill shot is a supersonic anti-ship cruise missile fired from a mountain cave. A small patrol boat does not have the massive multi-megawatt radar required to see a supersonic sea-skimming missiles coming, nor the heavy interceptors to stop it. If you send in small ships, they just become target practice for the heavy artillery. Big ships run out of ammo, small ships run out of luck. And you're still trying to protect ultra-large crude carriers, slow-moving walls of steel that max out at 17 miles per hour. You simply don't have enough ships, big or small, to babysit a continuous 21 million barrel conveyor belt. Look at the map again. So, if the Navy cannot secure the water, why not bypass? There seemed to be an obvious loophole. If the Strait of Hormuz is such a geographical trap, why don't Saudi Arabia and the UAE just pump their crude over land to the Red Sea or the Gulf of Oman? Why not just bypass the choke point entirely? Yes, the Saudi East-West pipeline and the UAE's Fujairah pipeline exist, but combined, they're maxed out. Even if you push them to their absolute bursting pressure, they can only offset roughly 5 to 6 million barrels a day. You're trying to shove 21 million barrels of maritime flow through a garden hose. If Hormuz is blocked, over 15 million barrels of daily heavy baseload are instantly trapped in the Persian Gulf. The bypass exists, but the math fails. There is no true backup system. So, the final desperate solution, just store it, right? Pump the oil into massive tanks and floating super tankers until the war ends and the strait is cleared. But the entire infrastructure of the Middle East, from the underground wells to the coastal storage tank, is actually one continuous, unbroken plumbing circuit. Even with their massive reserves, you run out of empty steel in a matter of weeks against a daily flow of that magnitude. And because everything is physically connected, what happens when those coastal tanks hit 100% capacity? The backup travels backward down the pipe. With nowhere for the fluid to go, you're forced to shut down the wellheads at the source. You have to physically turn off the oil fields. Storage isn't a solution. It is just a ticking clock until the geological engine of the Middle East completely chokes on its own supply. But the most dangerous blind spot in the mainstream narrative is that they think the Strait of Hormuz is just about oil. It's not. Roughly 20% of the world's liquefied natural gas, or LNG, passes through this exact same choke point, almost entirely out of Qatar. You cannot put LNG into those overland crude pipelines, and you cannot relocate Qatar's multi-billion-dollar coastal liquefaction facilities. If the strait closes, 1/5 of the world's natural gas instantly transforms from a premium energy asset into a stranded, useless monument. And it gets worse. Look at the obscure chemical byproducts. Over 40% of global seaborne sulfur exports move through Hormuz. Why so much? Because Middle Eastern oil is famously sour, heavily contaminated with corrosive hydrogen sulfide. Before they can sell a single drop of that oil to the global market, they are forced to chemically scrub the sulfur out. It is the inescapable, mandatory byproduct of their entire oil empire. Without sulfur, you cannot manufacture the phosphate fertilizers required to feed the global population. And more urgently for the tech sector, you cannot perform the solvent extraction required to mine and refine copper. And who is buying all of this? Roughly 80% of the material leaving Hormuz is heading east to China, India, Japan, and South Korea. Hormuz is not the American gas pump. It is the primary fuel line for the Asian industrial engine. East Asia relies on this heavy Middle Eastern baseload to run the largest refineries, shipyards, and manufacturing grids on Earth. And when Asia stops, the shockwave hits the West from the blind side. Look at Australia. They have almost zero domestic oil refining capacity left. They import the vast majority of their refined diesel and jet fuel directly from refineries in South Korea and Singapore. And where do those Asian refineries get their crude? The Strait of Hormuz. If that 21-mile choke point closes, Australia doesn't just lose its export revenue, Its domestic trucking, mining, and agriculture grids physically run out of diesel in a matter of weeks. The entire continent physically stops moving. And this exposes the ultimate vulnerability of the broader West. The United States and Europe spent the last 40 years offshoring their heavy manufacturing, smelting, and refining to Asia. We rely on the East for finished electronics, heavy machinery, automotive parts, and refined critical minerals. But the East relies on the Middle East for the sheer thermodynamic power to build them. We like to believe that the global economy is a resilient, decentralized network. But when you look at the physical map, that illusion shatters. The entire downstream manufacturing capacity of the Pacific and the Western economies that rely on it is physically held hostage by a 21-mile stretch of water. The Navy cannot force it open, the pipelines cannot bypass it, and the world cannot function without the molecules trapped inside it. If you want to know more, I have deeper dives related to Strait of Hormuz on the channel. Thank you for watching. I'll see you in the next one.